Hello,
All right.
everyone. Welcome back. This is our third time of doing this. Super excited to be back on again today. My name is Zach Dunham. I'm here from Bantam Tools. We're doing this every Friday, this Engineering from Home live stream series. And as I was just saying a moment ago to Ben and Chris and Nadya, this is like selfishly like a really amazing thing for me because I get to reconnect with friends and colleagues from around the country and around the world who I don't get to see anymore. This is an improvised event. Likely my daughter will come bursting in the room in any minute, and but we want to hear from you. So definitely jump into the chat and ask any questions that you all have. And today the goal is to talk about a couple things. Talk about education, some of the open source designs that we've seen emerge in COVID relief efforts, and talk a little bit about like the tools themselves. Anyway, before we jump in, I want to let's do a round robin. Ben, Chris, Nadya, do you want to? I'll just introduce yourselves and say we've got pretty good collection across the country too. So where you're from and what you do.
Sure. I guess I'll go first. Hi, I'm Ben Light. I teach at NYU in a grad program called Interactive Telecommunications Program, or ITP. I teach fabrication and design. Used to be an engineer. Used to be a designer. I guess I'm an educator now. I am currently in Pennsylvania in my sister's lake house. We escaped from New York, so I have a very makeshift shop, and I am away from all of my tools at the moment, except for very few. So it's been interesting. So thanks for having me.
Nadya, jump in.
Okay. Hi, I'm Nadya Peek. I am an assistant professor at the University of Washington in Seattle. I run a lab called Machine Agency. We're focused on the precision of machines, but the creativity of individuals. So what can people do in low volume when you have access to precision as afforded by CNC? Yeah, I am at home. I have been at home for years. No, just kidding. And I live really close to my lab, and I can still get into it, but I've been trying to avoid it. But I did just drive over there and pull out an Opentrons. Sorry, sirens. I just went over there and pulled out an Opentrons and brought it to one of my grad students, Hannah Twigg-Smith, so she could move around liquids by herself. I took it and left it in her garage. I saw her at the end of her garage. Anyway.
I want to come. We'll come back to the point about the tools in low volume and high precision.
Hi, my name is Chris Gammell. I run the Amp Hour podcast along with Dave Jones. That's like a weekly electronics podcast.
It's the best.
We've had some really good guests so far. Nadya and Zach are two of them. Ben, I'm sure you'll be up on the list next.
Great.
And so I am a full-time electronics design consultant, and I use KiCad, an open source piece of software for making designs, and I talk about electronics a lot, including for contextual electronics, which is my online course where I teach using KiCad. So yeah, that's me.
Let's jump in right with just sort of a recap of what we've seen this week. We've been doing this for 3 weeks now. When we did the first Engineering from Home live stream, I think it was like maybe the day after Prusa had released the design that's now like everywhere, and everyone is printing and laser cutting face shields. There have been a couple other things that have popped up. There's like the Helpful Engineering group that has thousands and thousands of people in there. There's this feeling of like, can I jump in? How do I jump in? How do I help? There's so many people there. Like, if I have one printer and am I going to make an impact? And like lots of questions around this, but I want to hear from all of you of like, what has emerged in the last 2 weeks that you've seen and you're like, that is a really good thing. Like, let's do more of this. Or, this is really scaring me. Like, we shouldn't be turning our makerspace into a medical device factory at the moment.
One thing that I've seen that's really good is a lot of people who have PPE gloves and masks donating them to hospitals. Unopened PPE is, I think, accepted at all major hospitals right now in the US, and figuring out how to donate unopened N95 masks and surgical masks, if you have them, is like the most important thing I think that's happening right now.
Yeah, we did that. One of the first weeks we closed our doors, we had a couple of students who came in and just said, hey, can we take everything? And it was like, yes, just do it now. And whoever the closest one, we wanted to keep it sort of in our neighborhood, but really whoever was asking, whoever was accepting with PPE. And that was immediate. And then it felt like, oh, what do we do now? And that's when I was turned on to these face shields, the printing of the face shields. And I've heard about ventilator projects, which scares me, frankly, as just being responsible for those designs.
I'm going to say, like, I've been trying not to be too much of a huge killjoy here, but people who haven't been making things a lot before, people who haven't designed medical devices before, people who are not used to working with stakeholders who are at risk groups, maybe shouldn't be starting right now. I understand that like there is this idea of like, oh my God, I have like this tool here, me and my Prusa, we can like make a difference. But 3D printing is not a good way to make a lot of the same thing. 3D printing is not a good way to make things that are easily sterilizable. 3D printing in lots of different places where lots of people touch things and assemble things is not a good way to do supply chain where we need scaled up response fast. And 3D printing is maybe a good way of prototyping things to see if the design is good. And I am a big proponent of open source hardware, or I'm on the board of the Open Source Hardware Association. I'm really much in favor of that. But I think that that's, open source hardware is a design, it's an attribute of a design, and getting feedback from people, from experts on what works as design, what are the constraints that we're working with, as engineers, that's what you do. You figure out, these are the constraints, these are the opportunities, and this is how we're going to solve this. Mm-hmm. And it doesn't necessarily mean that we should also take on manufacturing. Right. And ventilators, that's some of the ventilator projects that are happening now where they're like, let's start a hackathon and like try to make a $500 ventilator in like the next 2 weeks. There were people who worked on that for a long time. Reasons that those don't exist yet are like real reasons.
I guess the interesting thing there is that those aren't just like springing up in people's garages. Like Mass General is like sponsoring one of those, right?
Right.
Like that's the one that I know of.
The Covent.
Yep. Yeah. The thing that's interesting about that too, though, is that the deadline for the design is June or July. I actually had the opposite response. I was like, wait, that's too long. Like if the deadline for the submission is June or July and then production, we're talking about fall. But I mean, like I hear your point of like
the COVID-19, the MGH one, I think is an interesting one because if you look at the team of people who are involved, those are all MDs. Those are all people who know the constraints of the problem. And that kind of timeline seems much more realistic to me than the other thing that you see is a lot of people who are trying to redesign mechanical pumps for the ambu bags. And that just seems, and medical people seem to think that that's a really bad idea. I think that some kind of, the biggest thing that seems to be lacking is organization, logistics, and supply chain for all of these things. And after that, understanding also what the real need is. If you go to the FDA website and look up 3D printed medical devices, in its FAQ, it says, 3D printed PPE maybe can stop some stuff, but it is unlikely to perform nearly as well as N95 masks and surgical masks. Mm-hmm. And those are the things that we need right now.
One thing that's been interesting is been the shift towards the more simplified kind of like things people can do. I actually have been really, I think a lot of it started with the ventilators, and then the the complexities that Ben and Nadia mentioned, like, kind of sunk in, and they're like, oh, okay, well, what can we really do? And I think the Prusa thing's great. I think the, like more and more simplified, designs on the PPE that is there is great. So that's been a really beneficial thing. But I think, like Nadia's saying too, like there are of course constraints that, so I think that hopefully there's other things that people can do to pitch in.
But there's a lot of other things that you can do that don't necessarily have to do with like making electromechanical devices. Like there are a lot of food banks that need volunteers now. There are ways in which you can give money to food banks, to people who are in much more precarious situations than we are.
Yeah. It's I don't want to get too far off the topic of this, but that was something that I was really feeling today. It was like the things that I'm doing, like I'm not hacking on electronics in my basement. I'm like planting. Yeah. William Burke says, give blood. But I'm like, we're like planting vegetables right now. And
Victory Garden.
Victory Garden. Our like library has a seed bank. And it's interesting
cool.
of the more low tech things that become important. But Nadia, you I just want to get back to this one thing that you were talking about of like, using these tools more for the prototyping and R&D purpose that they're originally intended for, rather than mass production. Like what would you love to see then people working on like, let's take the example of, we have, a dozen 3D printers. What would you like those people to be doing if they have the time and the ability?
I don't know about 3D printers, but I collaborate a lot with James Coleman, who was one of my classmates, and he has like the Silhouette Cameo, the little vinyl cutter, and he was prototyping things for face shields as well, because that seems like something that maybe doesn't have the same material science requirements as the masks, for something that can be die cut.
Right.
And a die is, maybe $1,000, $2,000. And then you can make 10,000, 20,000 you can stamp out 10,000, 20,000 of those designs a day. And that kind of scale seems good. And when he was talking to, he's based in Kansas City now. When he was talking to a local die cutter, the die cutter said, yeah, we can't get PET G right now. No one seems, it's out at least 12 weeks at the supplier. So, one thing, I guess, like if you're like trying to buy, the thing that seems really bad is that everyone is trying to buy the same things at the same time, driving up cost and not necessarily producing the products that are needed. So I would almost say, if you have a 3D printer hanging around and you have filament, stay sane, stay home, wash your hands. Don't go out and try to distribute objects that you've touched to lots of different places.
Or Nadia is saying to also, make some PET G on huge industrial rolls in your house. That's also another option.
Yeah.
Really,
depending
really
on your
step
house.
it up. Yeah.
Depending on your house, like if you have a lot of stuff.
It's funny you brought up the PET G. I've had some students and some colleagues who've been printing these face shields, and the biggest roadblock is PET G.
Right.
And they cannot get their hands on it. They want anti-fog, very specific.
Right.
And I'm kind of curious when, and they were being asked by medical professionals for these, let's call them prototypes. And I'm curious what happens when we don't have the ideal. What's the next, what is the low-hanging fruit that's okay enough? And I wonder when those decisions get made.
That's the kind of thing where if you had the centralized response where you're like, okay, these are the opportunities that we have, and you solicit feedback from people who know answers to those kinds of questions that Ben are raised. Like, what is good enough? Like, I don't know. I know I was looking at a standard for how you test face mask performance. Mm-hmm. And it requires, I was looking at the test apparatus that is required for this standard, and just glancing at it, for the valves, the impactor column, all of the different parts in it, I would estimate that it's approximately a $15,000 device to do the testing. And do people already have that hanging out? what are ways in which that response can be coordinated? I think it's much more important than saying, oh, I think that we should just try putting t-shirts over our faces and maybe that'll be good.
A reason to join next week as well. I will just say right now, next week, this wonderful woman from Other Lab, Carly Mick, is going to join, and she's a textiles and material science person. And the goal is to get her take on this now emerging request that we all wear face masks. And yeah, I don't know. I think that Nadia, your point is like, I am very much largely in agreement with what you're saying, and yet the desire to use these tools is so strong that it's hard not to put them into the fight. And
right.
Like a couple people in the comments are saying, yeah, like basically to Ben's point, yeah, but like what's something that's still helpful, better than nothing kind of thing. It's yeah,
I mean,
it's just
if
tricky.
we had lots of
machines.
solutions, we wouldn't be in this predicament.
Yeah, it does feel like the Zach and I were talking a couple days ago. I remember feeling the same way. I'm sure a lot of people are making these connections that during 9/11 there was this need to help, and there was very little outlet. So everyone gave blood, and there was a point where they were just turning people away unless they were the universal donor, which is O positive, I think. And
O negative.
O negative. And so unless you're O negative, go away, because we're actually throwing blood away now because there's too much. So there's sort of this constant correcting that we want to help. We're helping too much. We're affecting, no one can get the right materials. Okay, so how do we do that? Yeah. And it feels like it's going to ping pong back and forth a lot.
The thing that feels like it's emerging too is just like the local level, and the thing that's, I guess, really nice about this moment, or I guess like a silver lining of this moment, right, is in the way in which like communities are coming together on like a local level. And like, so like here in Phillipstown, there was like a nurse who was like, we don't have any masks. Like, I don't have any masks. If someone has a mask, can they please donate it to me, because I'm going into work tomorrow. And I think in that sense, where you have someone who is like, they see the Prusa shield, they have the printer, they can make that direct contribution. And it's not this like, all right, let's organize all the people who have printers and vinyl cutters and laser cutters to then supply all of the hospitals. It's more of this like, I know you, I can make a tool for you. I know you, I can make a mechanism for you.
And that's kind of isn't that sort of this desktop digital fabrication kind of utopia, right? Like you had the exact need and you could solve it. And so in a weird way, on that level, it does seem to be kind of delivering.
Well, let's talk about tools. Chris, you wanted to talk about tools.
I did. Well, I mean, I think we'd all kind of mentioned at the beginning before we started recording too, and it's just we're away from our tools. And so from a teaching perspective, there's that. But then, from my perspective, I'm out of a shared workspace. I brought as much of my lab home as I could, but it's not my, like makeshift labs are not labs, and, being away from tools when they're critical to a process is troublesome. So I think one thing that I always push for in contextual electronics was, kind of keeping that in mind and like, what's a lowest common denominator type of tool, and finding like kind of like a Swiss Army knife type of thing. If you are in a place where you can't have the best tool for the job, what is the generic tool for for everyone that's not going to break the bank? Maybe that exists in the mechanical world too. I'm not sure.
No, it's I'm in a exact same spot. Having everything I needed, having it where I needed it, and now realizing what I forgot to bring when I kind of got my bug out bag together. It's like, oh, I need this, and then and it's crazy what small little thing can really hold you up.
Yeah, I'm really realizing what a
that.
huge snowflake I am. I'm like, oh, this desk is too low, and like, oh, this chair is uncomfortable, and I don't have enough power outlets. Wham, 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 wham.
Well, I was sold on the promise that someone had said about this like reconfigurable machine that I could just have like linear axes that I paste together and then rotational ones. Nadia, what's the hold up here? Come on.
I do have a lot of machines, but using my computer is a major roadblock in my life right now.
Yeah.
Yeah, I guess I have a lot of machines at home. Using them is not necessarily like I don't necessarily have big roadblocks to using them. But the other thing you realize is you don't have everything. And so I'm like, oh, I have this 3D printer, but I don't have like glue sticks for the bottom. I don't have like this scraper thing that I normally like. There's just like stuff where I'm like, let me go look in the kitchen if there's this thing that I normally have.
MacGyvering more things than normal, right?
Yeah.
Where are all my rubber bands and all my paper clips because they're going to become.
I only have
tools.
10 types of tape at home, and I definitely need all 24.
Well, it's kind of an interesting moment too, right? Like I'm gonna do a bad job at summarizing these, but like the Fab Foundation to some extent, right, has this larger purpose of just sort of creating this universal tool set to as an equalizing force, and yet the challenge with some of these tools, like we're finding out, best case scenario, you're like, I don't have enough outlets. Worst case scenario, you're like, we don't have power. How do we use this tool? It's kind of and it's an interesting moment shining a light maybe on some of the weaknesses and the strengths of these tools in this scenario.
Well, also some of the tools in the Fab Foundation, like there's a lot and they're pricey, right? So like,
I guess I'm referring to more the ones that are like distributed, like your Nadia, help me out here.
I don't know what you're talking about.
Well, I guess I'm thinking of like your project where you like literally built a modular CNC out of cardboard.
Oh, right. Right.
Like things that are low cost.
Okay. Yeah. Well, so the machines that make project where we like make open source hardware designs for machines, and then you can make them so that you have tools at home that have digital fabrication capability. I think that the thing to keep in mind is that a tool, like one tool on its own, is never that useful. You always need like all the other stuff to go with it. So you can plot things with a cardboard CNC, or you can cut tubes with a cardboard CNC, but then you also need something to make the connectors, or you need something to make the fasteners. And I would say that for me, the machines that make project and also the modular, like making modular machines, the main thing I think is important about that is what are ways in which we can hack and change digital fabrication tools. Making like shrunken tiny versions of industrial tools and putting them in people's houses is not going to meet people's needs, because we don't actually all need tiny and shrunken versions of the things that we normally buy.
Except for Bantwell's Mill, of course.
There'll be one clear exception here.
Of course. I mean, come on.
Well, the Bantam Tools Mill is for prototyping circuit boards, Chris. Geez, those are always tiny. But I guess at least a lot of my agenda there is what does it mean to need precision, and how can you deploy that? So with say we were trying to figure out faster ways of doing diagnostics for if we wanted to ramp up testing in different ways. What are ways in which you can design those kinds of protocols? Or like there's software components, there's electronics components, and there's mechanical components. And can we use that in the same way that you otherwise are using like paint and paintbrushes?
Yeah, today we're donating a machine to somebody who's doing an open PCR thing to try and make testing more widely available. Yeah, I think it's a good. It's a decent potential app. Anyway, I didn't want to.
Totally.
So like the question is kind of like, are there generic enough tools that could be specified in cases like this where maybe there isn't as much, like Nadia's talking about, like there's less precision required, but there are, like this is a case where, yes, you have a hammer, everything looks like a nail, but now we have very specific nails we need to be hitting, and can we use that hammer in this case?
And well, go ahead, Ben.
No, and it does seem like those that have never used that specific hammer think it's kind of a magic hammer too, and that it can do a lot more than it can. And whenever you show a 3D printer to someone, for example, the first time, it's like, oh, I can make anything. It's like, yes, maybe.
Except for hamburgers.
Yeah, so right. So it is kind of we've got these magic tools that can save us. It's like, well, they're still tools. There's still a development time. There's not this. Yes, it can print a part quickly, but it can't print the mass-produced thing quickly. Or there are these limitations that I think get kind of forgotten when we talk about these amazing machines that we all have now, and
also the way that we share things for it, and the way that we can modify the things that are shared.
And that's the powerful thing, right? I'm seeing everyone sharing. Not that it was that close to the community before, but it's like, here's the information. Here's the machine.
I would say there's like fundamental drawbacks to component or parts of the infrastructure in the machine that make sharing really difficult. Like if I design things in SolidWorks and you don't have SolidWorks, or if I have educational SolidWorks and you don't have SolidWorks is basically the worst case scenario, or maybe CATIA. CATIA is maybe the worst case scenario. And that if I were, even if I had say I have a design and I create a feature like a pin, and the feature, as I design it, I know, oh, this is going to have this kind of load, or I expect this kind of load, and I'm going to make it and this big because of that, or I'm going to make it go in that direction. That kind of design intent is lost when you try to share something. Someone else can then take it and be like, oh, cool, I'm going to make this gear twice as big. It'll be fine. And there's no way to really express that kind of design intent. Unless you like start adding a lot of notes, and how does that even work? And so I would say that if anything one of the things that I hope comes out of this is understanding how it's like a inertia of understanding how distributed design and distributed quality control are important questions that are under addressed, and we need to start figuring out. Like if I make a modification to a design, how do I test that it's still going to do the same thing? How do I ship unit tests for hardware that, not the kind of hardware that Chris makes, like chairs and stuff.
A unit test for a chair is called a butt. Maybe there's a universal butt,
yeah, but they're not a universal butt. Some people's butts are super different. Some girls' butts are bigger than others. Some girls' mothers are not.
Well, question I have is actually, on the fabrication. So, Nadya, Ben, you both run fabrication spaces. Is there like a minimum tool set that you tell people? I mean, you're both talking about working from home too. Is there like you definitely need like an X-Acto and some duct tape and this and this. Is there like a minimum set you should have at home?
It's definitely changed in the last couple of weeks. What I would have said 2 months ago is almost completely different now. And I'm talking to students who share an apartment in Brooklyn with 4 other roommates, kind of as our typical student.
Oh, yeah.
So it's not like they have a garage or even a kitchen table maybe. So the tool set is, all right, if you have cardboard, it's X-Acto knife, it's glue, it's tape, it's like a ruler. That's where we're at right now. And in fact, we're, at least for this one experimental trial class, we're sending out those Cameo silhouettes because it's the most affordable we can find, like a digital fabrication. And it's incredibly useful. It's not nearly as sexy. It's not nearly as impressive as a 5-axis blah, 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 but it is usable.
Tool changer.
Yeah. But
gotta cut out that aluminum helmet at some point.
Yeah, it's made for hobbyists, right? And scrapbookers. Yeah. And we're going to try and, I'm sure someone's going to be trying to do masks, and someone's going to be trying to do some really, hopefully interesting, forward-thinking stuff. But yeah, the tools are very different. It's an X-Acto or something digital fabrication of some kind, but the middle is hard.
Something similar. I am also teaching digital fabrication this quarter to the HCDE master's students. And I was like very apologetic, but I was like, listen, we can't come to campus this quarter, and I don't know exactly how we can run this class. I made a bill of materials that includes digital calipers, cutting mat, straight edge, X-Acto, and an Ender 3 Pro.
Yeah, it's kind of, I have students who don't have a drill, don't have screwdrivers, because they come to our shop and we provide them. And, a glue gun is now maybe one of the more important things, which was like, you never use a glue gun in my class. And now it's like, get a glue gun, because this is the new normal. Yeah.
I did an anonymous survey at the beginning of class about what was going on. And one of the students was like, you're very cool, and I was really excited about this class, but it's just not cool enough. Just 3D printing and CAD is just not enough. Last year, people were able to do much cooler stuff. And you're like, okay, yeah, last year was different. I agree.
Well, that's funny, because I am worried my class might turn into a CAD class. And,
my class is definitely partially turning into a CAD
and
class.
I so don't want that. I hate CAD.
What is the actual, so what is the normal case? Maybe you could both explain that too.
Thanks, Chris.
Okay, Zach, I'm just, I'm in interview mode, even though I'm one of the interviewees. My bad.
No, please.
So the class I'm teaching right now is it's called Subtraction, and it's half digital fabrication, half typical wood shop, power tool, manual, removing of material from a big block, whether it's a 4-axis CNC, a hand router, a wood lathe, all of these hands-on tools that, there's software, and yes, there's CAD, but it's really getting through the whole process to see what's the right CAD for the right tool and how that affects. And so it's time on the machine is what I really say is the class. And we got about halfway through it, and the next tool we were going to learn was the lathe. And there's no way to teach the lathe remotely. And I don't even like teaching the number of students I have the lathe. I like one-on-one kind of tutorial. And
there's a video I saw on YouTube where a guy took a tree stump and he put it onto the back of his Ford pickup, and he was using that as the rotational axis. And then a couple butter knives and a really solid thing to lean
against. These are Brooklyn guys. They don't have cars. We don't.
It's like you're hiring an Uber and taking off a wheel or something. Yeah. Hourly rate's really high for that.
If you tip well.
Yeah. Right. Yeah, that is tough though, because it's it is so tied in. Into the.
So basically, week one, we're like, this class changed. This is not what any of us signed up for. There's no way to go forward with what we planned. So we are going to be true to the spirit of the class, but it's going to be, very different. And the first class was basically a lecture, and man, we're doing everything through Zoom. And whether the class is killing or dying, it's the same. You hear nothing because everyone's muted and have their cameras off. So it feels like it's just going off into the void, and it's awful. I don't like it. And not having these demos, which were sort of like my superpower to show everybody, and now they're gone. Or, hey, let's find a video online that's doing this. It feels really, it feels like we are cheating our students a little bit, even though, it's everybody's getting cheated. So that's why we're relying on these final cutters. That I'm getting emails coming in from my students like, it just came, it's great, So there's a bit of excitement, and we're going to live in that 2.5 axis world for a little while, and just push it as far as we can and see what we can do. So I don't know, Nadia, what are you doing with your students?
Well, so we're in a quarter system. So our quarter just started last week, and normally I would be teaching digital fabrication, and they have access to several maker spaces on campus, and they have big laser cutters there, and big format mills, and water jet cutter, and lots of machine tools, and lots of normal manual tools too, and space to actually work. And so now everyone is working on their own at home one of the major things I think is missing is also just getting students normally help each other a lot. And you learn, I'm fully expect that students learn much more from each other than they learn from me. Because I'm always like, oh yeah, you just do this like this. And they're like, we have no idea what you just did. What a useless professor. And that now all of that peer learning is like really disrupted. So I've been trying to use the Zoom breakout room function.
Yeah, me too. Yeah.
Ooh, that's a good tip.
Yeah.
I don't know if it works though, right? Like
I think it works. You give them a task and then they help each other. And if they're all in the same room, they don't talk. But then I sometimes go into the breakout room. All of a sudden, I'm like, hello. And they're talking to each other. They're like, oh. I'm like, okay, I'll leave again.
Yeah, it's a weird, it's very strange. I agree with the not having the peer group. And I think not loneliness is not the right word, but they used to live in the shop, and now they live where they live, and it's like, this was not what I signed up for, and
I didn't add
that energy's gone.
CAD stuff to my class where normally I teach mostly just 2D CAD and like simple extrusions that then they make stuff with, and now because we just are living more in computer world, I'm just doing like full 3D CADs and rendering and other things. So I'm like, this is not something that was in the class beforehand. And I know that learning CAD is annoying and not everyone loves it, but it is annoying for everyone. So after this class, you will know how to do this. You will have gotten through the annoying part. And then, it was at the same time as other annoying things will happen. So maybe the part about learning CAD isn't the most salient detail in your mind.
Learning CAD is annoying. You're absolutely right.
Chris, you've been teaching stuff online for a while now.
Yeah, I was gonna bring that up too. Yeah, it sucks. I mean, that's the takeaway. Here was like some of the constraints that I kind of ran into when I first started thinking about teaching electronics online. One is they were paying me, and that meant that there was less money to pay for gear, right? And that's like, so now, okay, people might be coming in with, a full lab of equipment, but someone might be coming in with like, literally, they're like a software person, like, yeah, I want to learn electronics. What do I need? And I'm like, well, get out the credit card because you're going to need a ton of stuff. And so it was like, okay, so first thing is like, what is the bare minimum? So like Ben was talking about too, like, what is the bare minimum we can get away with? And it was basically like, follow Dave Jones's $50 DMM thingy, low cost, thank God for Amazon, and, just like being able to get, not everything the same either, but like low cost soldering iron, low cost oscilloscope. That was really tough up until recently, because an oscilloscope, the decent oscilloscope is a couple $100. So like that right there,
you live in now though. A couple $100, imagine.
Yeah, right.
Tell your childhood self that.
Yeah, of course, right. But basically, asking someone to pay, basically then it's like $1,000 to get started with electronics. That's a really tough ask, and really just not tenable. I mean, like that. So, anyways, and that was all before you even got any components, right? Electronics, it scales directly with the cost of your components, and like the more complex thing you want to do, the more the parts cost, right? It's not like I'm not making it simpler that way, but like, you could do a lot of interesting things with a piece of wood, and the complexity comes in the amount of processing time on it. Whereas however much time you spend on a resistor, it will never be an FPGA. So that is kind of the trade-off there.
I need that on a t-shirt.
Yeah, right. So then the real thing is, and I think this is what Nadya and Ben were talking about too, is like, okay, so now you get to this point and you're like, you follow along, like the whole idea was kind of like, the reason I called it like an apprenticeship is because the best I could do at a certain point was like, you might not get everything I'm doing, but you can follow along exactly what I'm doing. Here's where you click. Here's where you do this. Like let's form some muscle memory in CAD and in electronics, because you need lots of cycles to really get things clicking in your brain anyways. Like, why am I doing this? Why am I always putting a resistor with an LED? It doesn't make any sense to me. But if you do it enough times, you start talking about current, and you start to kind of piece all this stuff together. So it was really about like getting repetition, even if it was just dragging people along with me. And that part sucks, right? I mean, because people have questions. So I had one student, we started getting into like op amps, right? The very common electrical component, something I like talking about a lot. But we start talking about, he's like, I didn't get op amps at the beginning. And so then I went to Wikipedia and I've been here for 5 hours and I don't know anything. And I'm like, yeah, don't do that. Like, and so you have to basically try to like narrow people's vision down too, of like, there's this whole wide world of things you could do, but now you have to try and like, be like, no, just follow me. It's just like dragging people, just follow me on this one thing. And we're just going to do this one thing. Okay. So now you said you're doing that. And then at the end of it, it's like, now people are following you. And they still doesn't work. And so now you get people like Nadya's saying, like, you're trying to get people to talk to one another. That is a good scenario, but then you get 4 people in a room and 3 of them are like, yeah, I don't know. And so, yeah, so learn, like, so first off, I think that is one thing that I had a lot of humility about after the fact is like, really good educational instruction, like educational design rather, is like important, having learning outcomes. And I did a lot of reading at my local library about how to be a teacher because I thought I could do it for some reason without actually learning about it. So I had to go learn that kind of stuff.
That's also what they think about all professors. You like spend all of your time alone doing research and then you become a professor and they're like, cool, now you teach.
Right. Exactly. And educational design is really important, and having learning outcomes and following those kind of things. But assuming you have all this stuff and you follow all this stuff down the line, I think it is important to let people struggle a lot more than my nature was, right? And so like being like them telling like, hey, I can't figure this out. No, well, keep trying, And this is something I know professors are good at because that's all I ever got in school. Hey. But I think then it comes back
the surprising part also about that is what learning is. I think it's easy to think like, oh, if this professor or this teacher were better, then I would know things without having to like have this painful struggling moment of like what is going on in this interface or what is going on with this feedback loop. And that's just not the reality of learning. And I feel like you're at risk of being like, back in the day, we spent much more time. But I do think that basically you want to learn something, you got to spend thousands of hours doing it.
Yeah,
I agree with that.
One thing is breaking it down into smaller pieces that it like, there are dopamine hits too. That's another thing that I've learned is like, if you get these dopamine hits and you have these small chunks, that's one thing that good learning outcomes are based on, is like having these small things that people can be like, oh, I got that. Great. I can maybe do the next thing.
Yes. Yeah, I think it's 100% about building self-confidence where you are like helping them through this journey and you're like, here's where you're going. You're fine. You're doing this. This is good. Like this is what is supposed to be happening.
Right.
And then they're there. And then it's funny sometimes with students and learning within like a week or two, they're like, oh yeah, that's easy. How do you not get that?
Right. That's why you need to like do a video capture of like what they were doing before.
No, it's the whole point. It's I like it's like a kind of inception where they're like, this is impossible. And then a quarter later, they're like, I know everything about this.
Right. That's the training montage.
Yeah. Don't you think though that I guess that's an opportunity though right now is that everyone is forced to be so much more independent in their struggle right now because we are all learning and working and doing everything much more independently than we were.
So like in the old days, it would have been like, hey, can I copy your homework? And now it's like, hey, can you share your screen?
No, I guess just because these tools break down, right? Like, well, I don't know. I assume that like your students aren't on a literal Zoom video chat 8 hours, 10 hours out of the day. Like some of that time they're now working on this solo and they're not in that shared fabrication space where they can like look over their person's shoulder and say like, oh, how did you wire that circuit? Right. It's like, no, I am here in my desk and
right now I have to schedule a 15-minute Zoom session with someone to
sure, Chris.
Look at their desk.
Yeah.
Well, I hope that's the hope, right? That they are getting that independent, teaming to work out. But I do think there is this, they have time too. I think everyone's sort of, you don't have to commute. You don't have to.
Some people have time.
Shower.
Some people are also running homeschools or caring.
Oh, totally. I'm talking my typical student, which is sitting in their apartment, staring at their roommates, and they're like looking for anything to kind of like take up their time. There is on the flip side, like glass half full, there is time. I'm kind of trying to figure out what do I want to teach myself while I have this, for lack of a better word, luxury.
This is not the experience I have at all. I have like
oh really
8 hours a day that I have dedicated to just panicking, and then in the remaining time I can maybe try to do stuff.
Yeah,
I'm more in that boat. Actually, there's like a New York Times headline or something that I saw yesterday about like all the free time to like do all those projects. No, I'm just like or like another one that was like stop trying to be productive.
yeah.
Oh wow, really?
Which another thing, I guess, and I guess one of the questions I have too is like, all right, so this is happening. The fall semester, I assume that you professor and educator people are talking about like, how the hell are we going to do this come fall? Like this, I can't imagine how this won't have like a total sea change on the way in which like.
Well, one thing I don't know
is
if this is happening to you guys, but the thing that I already see kind of happening is they're like, oh, your class was limited enrollment to 40 before because you had this classroom restriction, but now you have all this online content. Let's up your enrollment to 200.
There's so much money available now.
Wow,
no problem.
Billions.
And
I've not heard that.
You've always said that you needed like several TAs to help you with the content. But if you just record your lectures, then like you can be that person who helps everyone too. And you can just reuse them every year. Who needs personal attention? This is not part of learning at all.
Right.
You just see all the associate deans going.
Right. Digitize everything. This is the realization.
Yeah, what's the point? What's the point of university? Like, what's the point? You can learn everything online at home. Like,
that sounds like a terrible outcome.
Well, I think some of it's motivation. I mean, like we're kind of getting at it too, right? I mean, like Ben's talking about, it's like, you literally all of us could, if so all right, I grant all of you $1 million a year. It's like you can go learn anything. It's like, okay, now what? Like, are you motivated to go actually do that? It's like that's
right.
Having skin in the game is a really important piece, I think, and that's one thing that I personally think that university does is like, hey, I plunked down a lot of future cash or current cash, and it's like I want resources, but I've said I'm going to do this thing, and I'm going to do it. So
that's part of it. I think part of it is also like the social environment that you're in, where you're working on teams, you're figuring out who you are, you're figuring out what you're good at. That's an important component of it. But I do say, there's also another, this is sort of before COVID-19 already percolating as a fear. There are also just less, there are fewer young people. In 10, 15 years, enrollment in universities is just universally going to go down because there are fewer young people. And what is that going to mean? You have all these people who are like, oh yeah, I'm 50. Like everybody wants to learn KiCad, right? Nothing new has happened.
Well, that's a large part of my. But yeah, I mean, it's not like I'm growing.
That wasn't meant as a subtlety. Yeah, I think that what are we doing and how are we changing is going to be, there's going to be some cool opportunities. Like I really do want to understand how we can do distributed design well. I want to understand how we can do distributed quality control. I want to understand how we can collaborate remotely. Those are all, I think, good things. But then there are other dangerous things that I think could happen where people are like, oh no, we need to close our borders. We need to have only local food production. We can no longer rely on other countries or states for importing phones, soybeans. There's already a nationalistic undercurrent to our contemporary society, and this has the potential of only exacerbating that, rather than saying like, oh, actually, we do need to build resilience in networks. We do need to figure out how we can what the fragility of the centralization of our of the way that we are trying to handle things now, and figuring out how we can prevent that kind of risk going forward.
Yeah, I mean, hopefully one positive aspect of it all is, I mean, I read a lot about like, reshoring, onshoring, all that stuff, and I think Nadia's right. There are some
last week, yeah.
Oh yeah, right. You guys did sourcing. I just watched some of that, yeah. And some of that is like important, but I think more so like the one positive thing that could come out of this is just a manufacturing mindset more than, maybe you don't have to make it down the road, but making it so that your design process and you're thinking about like design methods that actually could be manufactured. So that when you are ready to shift into high gear, you're ready to go. You're making test stands. You're making design for test, design for manufacture, design for repair, all that stuff. That is a positive thing to be thinking about, I think. Even if it's your design or your manufacturing is, behind a curtain. It doesn't matter where it happens.
We're actually, go ahead.
No, sorry, go ahead.
No, just to piggyback on that, we're actually pushing that on a very small scale for student projects where there's still these online, one-off kind of manufacturers, whether it's Shapeways for 3D printing or Send Cut Send for metal laser cutting or whatever. And what's different for our students, they don't have the access to just kind of invent and prototype on the fly. They have to design parts, send them, and have them shipped back. And it's a new mindset for our students anyway, where they had kind of the keys to the castle, and now they just kind of are seeing the future of what, if they go down this path professionally, that they're not going to have every machine. They're not going to have access to all of these amazing things where they have free reign to just kind of tool around on them. So
that is in a way how it has always been,
right. Yeah.
Historically,
no, it's good.
Industrial designers did not make things themselves necessarily. They made prototypes and then figured out stuff with manufacturers. And I think that
I think it's good. Yeah.
A good thing about this, like a month ago, AKA 15 million years ago, I was having a conversation with another person at my university who said, like, I've never heard of the word supply chain.
Just going to bring this up. Yeah.
Why do you always put jargon in everything you write? And now, like, that's definitely over. Like, people know what supply chain is now.
Yeah.
People know that there are like design phase, there's manufacturing phase. Manufacturing relies on material flows, and those things are all things that you have to constantly tend to and manage. And that is thousands.
And if I could use my earlier words, it sucks,
But yeah, like people will now be forced. Everyone is being forced to understand how things get made, how things get shipped, the networks that are relied on to actually make that happen. It can't happen just with government alone. Like what was the story 2 days ago? The Massachusetts governor got in touch with the Patriots team, I guess, to fly to China to
a million masks coming back or something.
Yeah. And it's like,
I don't know this. What was?
Well, it's like basically because people in our government have completely botched international relations. We don't have this way to be able to say like, hey, China, can you please send us, 1 million masks tomorrow? Okay. And so what's happening is you have private, companies and individuals who are like, oh, I know a guy. I know a person. I work in manufacturing. I work in overseas operations. And so
the technical term is guanxi.
Yeah, guanxi. But yeah, Nadia, to your point, like people will know how things are made.
Although it's
will no longer
slow,
be.
I mean, to come back to the earlier part of our conversation, like when you talk to someone who's like, I made 5 face shields today on my MakerBot, and then you're like, yeah, okay. Do you know the scale of mass manufacturing? We as humanity are super good at mass manufacturing.
Let's go watch a YouTube video about injection molding.
Yeah.
Awesome. I love injection molding. Actually, that's an interesting point of like, do you roll that in your educational pieces too? Like Ben, when you're teaching design, you have like one student pass another student thing, be like, all right, you're the manufacturer, you're the material sourcing, is that something you do?
It's definitely something. It's not something I've done, but I'm considering it. Where it's a you do the drawing and then send it, and then you don't say a word.
Yeah.
And
right,
the
like playing telephone, right?
Sends it back, and you're like, why do you make it this way? Because you drew it this way. And I think I remember when I was a young engineer, I was like, why did it get made this way? This is ridiculous. It's exactly how I drew it. And
I specified a 1 millimeter thick wall. Why would
it be one? Like they can see how thin this is, right? And And it's definitely probably going to be what we're doing in the next few weeks, just so that, one, to keep them interested, and two, that that's a learning curve again, when you're your own client and you have access to the material and the machine and the finished product, and you only need one. It's easy to just iterate, and not really focus on the iteration or learn from it. You just know that you have that. So when it does leave your hands, you better be sure. It's going to cost you money if it's wrong. So that's something new.
I taught a workshop, or I taught a kind of workshop like this, Chris, with James Coleman, who I worked on the cardboard machine kit with, where he separated workshop participants into 3 groups. You have the design group, you have the manufacturing group, and you have the field installation group. And the idea was that they're making like pavilion size installations. And there's a limited amount of material that they start with, and there's like 3 days for the workshop, and each team was only allowed a half-hour meeting a day with the other teams. So, and specifically, one of the things that was important for like the outcomes of the workshop was demonstrating that if you want to manufacture anything at scale, and here and in the context of a 3-day workshop, scale was like, we want to make 100 of something, not necessarily, or maybe 1,000 of something, but not 2. But not actual scale, the way that we're talking about needing PPE, and that they're getting people comfortable with prototyping tools that allow you to test or ship. Like if you're going to make one of the designs that one of the workshops made was all triangulated, like a whole triangulated surface where the surface was really irregular. So every triangle was unique. So how do you make sure that each triangle ends up in the, so they had to make, with the cardboard machine kit, they made a machine that makes triangles. Then they had to label each triangle. Then they had to ship the triangles to the team that was doing it.
Flat pack furniture.
Yeah, exactly. And
hire the entire class.
And that the thing that at least we were trying to demonstrate is that prototyping tools, like prototyping a tool where you figure out how you're going to do your shipping, or prototyping a tool where you're figuring out how you're going to adapt your design to the limited amount of material that you have, that those are all really important skills to have. So if you're just good at like making the most beautiful undulating triangulated surface, it doesn't really matter if you don't know how to adapt it to the materials that you have, if you don't know how to show it to people who are going to manufacture it, and those people who manufacture it don't know how to tell the installation crew how to build it. So
this
we
is like
proposed
architect meeting like construction crew kind of problems, right?
Yeah, exactly, yeah. A workshop we've been teaching at sort of architectural conferences, and it's been rewarding. And the thing that sometimes is difficult is that people see it and they're like, oh wow, these cardboard machines are so cute. I want to like hang out with my 5-year-old and this machine. And I'm like, no, what I'm really trying to teach you is how do you scale up? Like, I guess you didn't learn my learning outcomes. Okay.
It's like it sounds like a war game for manufacturing almost, like a
grand strategy.
Yeah, right.
But could be so useful in so many different industries.
Yeah. Totally.
Yeah, there's a business in there somewhere. Someone out there's watching, and they're like, "Yeah, I'm gonna make this a thing."
Please do. Please do.
I mean, I posed this question to Scott last week in last week's live stream, basically saying like, all right, if you were in control of this order to really nationalize U.S. manufacturers to start producing PPE, and these are, it's telling IBM to turn around and start making ventilators or whatever, like, how would that work? And he's like, well, it doesn't work like that. You can't just say like what we're missing is the entire infrastructure to be able to network all of these companies with the doctors, with the logistics people. Yeah. Like it's all the stuff up until the point to actually making. He was like, the making is the easy part. He's like, that's just like the design. And these are people that are, their job is to like follow processes and like run these machines. Like that's the easy stuff. The hard stuff is all of the infrastructure and the communication.
Yes.
Like,
let's talk about invoicing people. Let's talk about documentation.
Man, we're really hitting all the low notes today.
Yeah.
No, these are all the high notes. That's the thing. Like if you understand like where the pain points are though, like I think that like people that have dealt with this stuff of like, hey, talking on a 12-hour delay with your factory in China, like all of the things that like really are going to hit you and like you are going to be up nights sweating about, like you start to understand that like that's where the best people are at this kind of thing. Like, so like you said, like I don't know if IBM would be my example, but like, you know, you like get a really high functioning factory or, you know, manufacturing company. They're good in a lot of the ways that you never see, you know, like you don't get to see all of the you don't see their PLM, you don't see their, you know, you don't see like how their engineers interact in meetings and stuff like that. But that stuff is where it really pays dividends. So teach that, Nadia.
Yes.
We're at the we're at the 1 hour mark here, so I might wrap this up. This is so much fun. Despite all the low notes, yes. Next week we're going to have Carly Mick on to talk about all the talk of DIY face masks and the high-low tech of sewing machines, and a little bit of material science on like N95 filters and how those things are actually made. Ben, Nadia, Chris, thank you so much for making the time.
Thank you.
Joining and chatting and sharing all of your insights.
Thank you, Zach.
Thank you.
It was a lot of fun.
Stay safe. And we'll post a video of this on the Engineering from Home landing page on bantamtools.com and link out to Nadia and Ben and Chris. And we'll make some notes as well so people can follow along in case you missed it.
Good to see you, Chris. Nice to meet you, Ben.
Nice to meet you
Good seeing
guys.
y'all.
Yeah,
Have a great
thanks,
week.
Zach.
All right. See y'all.